There are three major structure types that you're going to need to know when doing work with event-driven programs. The first one I'm going to cover is the simplest, but probably the least used in as much as the programs you will be putting together. It's known as an enumerated type. Its keyword is enum, standing for enumerated type, and you give it a name. In this case I'm going to call mine direction, and then a list of values. Doesn't sound particularly exciting. What would you use it for? Well, say we were creating a game, for example, and your character could face four directions: north, south, east and west. There are various different ways we could do that. We could create a Boolean variable for each. And then perhaps every time we turned in that particular direction, we set that one to true and all the others to false. It's all well and good, it works, but not a particularly tidy way of doing it. Maybe we could use an integer, have it set to 0 for north, 1 for east, 2 for south and 3 for west. It would work, but again, it's not the most tidy way of doing it, because where in the code you're talking about if direction facing equals 0, you won't necessarily realise exactly what that means up until you go through all the code and find the information you need. It's much better to be able to just say which direction it is you're facing, and that's what the enumerated type is designed to do. Now, just like other formats that we've discussed already, enumerated types actually allow automatic conversions. You may say, that doesn't work. How can possibly an integer be direction.north? Well, enumerated types can actually be converted into numbers. The first item is 0, second is 1, the next one 2, and 3. So, if I make my label 1 that I've got currently set up on my form, to actually load up direction facing, you'll see that in direction north is 0, south is 1, and so on. So it works. However, sometimes we may actually want to see what the word is: north, south, east and west. I can use the toString basis to actually create the word on the screen. If I change the direction to south, I can view that. So this one item can be used to display a word on the screen and be used as an integer if need be at the same time. And it makes your code much easier to be able to work out what's actually going on. For example, if direction facing 2 equals direction south, I know I'm going south. So it makes it much easier for the programmer. That's an enumerated type. Sometimes we want to do a collection of variables and keep them all together. The way we do this is to use something called a struct or structure. Again, we need to give it a name. In this case, I'm going to create a player for my game. Again, I have curly brackets to identify all the items within it. Now in this case, I'm going to put a series of public variables in. I have to put public, otherwise you can't see them when you actually create the player object in the code. So every item within your struct has to be set as being public, just as a warning. You may notice I'm not setting life or score to a value like this, because if you watch, when I build my solution, you cannot have an initializer. So how do you actually use it? Well, you create a variable of type player. And use a new keyword for this one. And then I can set it within here. Player1.life equals 100 for percent. Player1.score equals 0. Structs are very simple and can only contain variables. Sometimes though, you may want to create something a bit more complicated. For this we need to create an object, which is known as classes. The first thing an object has to have is an initializer. This is a piece of code which sets the object up in the program. For example, say I want to have an enemy with a certain amount of life. I can actually initialize the amount of life within itself. So I can create an enemy and as soon as I use that new keyword there, new enemy, it runs this piece of code here. So his life will already be set to 10. Why would you need to put an enemy together like this? Because I don't have to just do variables, I can write code as well. And I can access this code in the same way as I can access variables. So I could have all the code that relates to the enemy together in that one object, rather than just have to have it within the form itself. This is known as object-oriented programming, and again is the basis on which event-driven programming has been formed. Between enumerated types, structures and objects, called classes, you should find you can create very complex programs in such a way that they are very easy to actually read as a human being and to keep making changes to as needed. For example, having an object such as enemy means that we can actually create multiple enemies on the screen at the same time. All we do is create multiple copies of our enemy object. We don't have to recreate all the code that goes with each object. We don't have to recreate all the variables with each object because they're all kept together in that one object and I can then access them.